Hello, my name is Mark Thomas, and I'm the president of Energy Engineering Corporation. We are the makers of the EcoShark power conditioning system. On your commercial power bill, you're going to be billed for several different things. The first of which is probably going to be kilowatt hours. You're also going to be billed for a problem known as power factor errors, and that is expressed as kVAR costs. You're probably going to be charged for some component of demand, and that might be peak demand. And peak demand is acquired over the course of the previous 12 months on a 15-minute billing cycle for the highest demand that your facility uses in that 15 minutes. Now, we're going to start with kilowatt hours because this is the most prevalent, or probably the number one line item on your power bill. How do we accomplish kilowatt hours? Well, you know, if we break kilowatt, because we know that kilo means 1,000. So if we take the kilo out, that leaves us with watt hours. Well, you know, a watt is a basic formula for power, or true power. Well, the simple equation for wattage is 1 volt times 1 amp is equal to 1 watt. Now, some power companies, like Georgia Power, for example, use a slightly more developed equation. Georgia Power uses a process known as volts times amps times power factor, which we'll discuss later, times the square root of 3 to accomplish or to develop your kilowatt hour charges. It's just that simple. The next item on your power bill may be something like kVAR charges. Sometimes in big buildings, kVAR charges can add up to big bucks. kVAR is a simple term known for kilovolt amps reactive. And kVAR errors, or power factor errors, occur when electric motors turn and are not perfectly wound. So, if we look at our phase cycle here, we know that in America we use a 60 cycle per second system. And we see this first line here as our voltage that we're delivering to the motor. And the second line may represent amperage that the motor is actually drawing. Well, as you can see in these shaded areas here, there's a difference between the voltage and the current. There's a difference between the voltage and the current. In fact, we could say that the voltage is leading the current. This shaded area represents the power factor error expressed in kVAR on your power bill. The next line item on your power bill may be some component of demand. Say, maybe it's peak demand. Well, peak demand is a function of a 15-minute billing cycle that runs all year long, and the highest point in that 15-minute cycle anywhere in the year is your peak demand for the next 12 months. So, if you can lower peak demand for this year, then you will reap the benefits of that for the next 12 months continuously. The EcoShark shunt-type power conditioner addresses each one of these issues here. It will lower your kilowatt hour consumption, which in turn reduces your peak demand. It will correct for power factor errors, which gives you a much lower kVAR costs on your power bill. And one thing that we don't talk about all that often is the EcoShark will actually correct for damaging harmonics that you can see on things like computer screens that jump around irregularly. That's harmonics in an electrical system. The EcoShark addresses every one of these problems, and based on our beta test that we accomplished at a commercial building in Atlanta, the EcoShark actually reduced kW consumption by nearly 20%. Now, we're not going to advertise 20% or 22%, which is what it actually was, because that might not be the case in every application. But you can probably expect somewhere in the neighborhood of 15 to 18% drop in kilowatt hour consumption. We also increased the power factor efficiency much closer to unity at something in the neighborhood of 16% increase. That's what we're seeing on average over electric motors that we've tested that include air handler motors, centrifugal chiller drive motors, feed water pump motors, this sort of thing. These are typical applications for the EcoShark. And that's about it. What? I can't.